All right, today we're going to talk about circles, and in this unit, I've been talking about areas of different polygons, like a triangle or a square, a rectangle. We did trapezoid, we did parallelogram, we did some rhombus work, and now today we're going to talk about circles, but you'll notice at the top it doesn't just say area. And that's because we're going to talk about more than area when it comes to a circle. So let's go ahead and dive right in. The area of a circle is, this is my definition, it's probably not very mathematical, but it's basically the space inside a circle. The space inside a circle, all right? All the space inside of a circle is its area. The circumference of a circle, on the other hand, is different, and I don't know why they call it a circumference. I've never looked it up. Maybe I should. But the circumference of a circle is the exact same thing as the perimeter of a circle. Okay? The perimeter of a circle. So it's the distance around a circle. The distance around a circle. Because you know what perimeter is at this point. Distance around circle. Okay, so we've got the area inside, and then we're also going to find like the perimeter of the circle, which is called the circumference. So we're going to talk about pi today. It's 3.14, which is right here on your screen. I'm going to actually use exact measurements in this set of notes here, so you're not going to have to use 3.14. I'm just going to use pi and leave it at pi. But you might not even know what pi is, and I'm going to write in regs. You don't have to write this down, but basically what pi is if I took this little radius right here, and I took him and laid him along the circle. He would lay along the circle one time, and now obviously my proportions look a little rough because I'm winging it here. 2 times, 3 times, and then this would be 0.14-ish. Okay, so 1, 2, 3, and 0.14 radii go on the circumference of a circle. Okay, that's where radius comes from. Now, you don't need to know that, but I thought I'd just let you know where it comes from. So what we're going to use is we're going to be using c equals 2 pi r. That will be the formula for circumference, or the perimeter of a circle. And we're going to dive right on in here. It says find the exact circumference of a circle. Exact means pi is in your answer. Okay, so if you're ever wondering if they say exact, just make sure pi is in your answer. So we have this circle for number 1, and we know that circumference is 2 times pi times r. Well, what is your radius? Now, we haven't talked about it yet, but the radius always starts in the center and goes out to the edge of a circle. So it starts in the center, goes out to the edge of a circle. So our radius in this picture is going to be 8. So circumference equals 2 times pi times 8. Let's clean this up a little bit. We're going to leave pi alone. Don't use 3.14. We're going to leave it exact. But let's do 8 times 2. And 8 times 2 then is 16. So 16 pi, I'm going to scooch this down, 16 pi is going to be your circumference. Now, we need units. Circumference is the perimeter of a circle. It's the distance around a circle. So is that going to be inches, or is that going to be inches squared? It's going to just be inches. If we did perimeter, we don't square it. So circumference and perimeter are the same here. It's just we're talking about a circle. Let's look at number 2. It looks a little different, okay? We know that circumference is 2 times pi times the radius. Well, the radius starts in the center and goes out to the edge of the circle, and what I'm seeing here is edge to edge. You see that? Edge to edge. So a radius would be here, and a radius would be here. So I could take 12, and I could divide it in 2. 12 actually is the diameter. Okay, and what you might not know is the diameter is the radius divided by 2. There are 2 radii in a diameter. So in this picture right here, my radius is 6. So this is what we're going to use in our formula. So the circumference equals 2 pi times the radius, and our radius in the picture is 6. Clean it on up. 2 times 6 is 12, so 12 pi. Remember, circumference is the perimeter of a circle, so you are not going to square your units. It's just the distance. I would like you to do 3 and bring that to class next time I see you. Complete 3. It's very similar to number 1, so you should be a-okay with it. Remember, you can always pause, rewind, do whatever you need to do when you're watching the video to learn at your own specific pace. All right, so let's keep on moving. So 4 and 5 have words in them, and what I've noticed with students is if it has words, they kind of don't want to do it, or they want to just ask me how to do it. You can do this. You can handle this. So I want you to watch how I do number 4, and then you're probably going to be doing number 5 tonight. Okay, the exact circumference of a circle is 18 pi feet. So let's pause. The exact circumference of a circle. Circumference of a circle. So we would use the circumference of a circle formula, which is at the top of your paper. C equals 2 pi r. Now they're telling us that that circumference is 18 pi feet. So is 18 pi the C or the R? It's going to be the C. So we put 18 pi here equals 2 times pi times r. We want to get r alone. So if we divide both sides by 2 pi, actually let's just divide by pi first. Let's just get rid of pi first. It's so confusing, I'm sure. So let's just get rid of that. See how it drops off of there? Super awesome. 2r. Okay, now what do we do here? 2 times r, so we're going to divide by 2, and we get 9. Now I'm noticing an issue down here. This says c equals. This is definitely going to be r equals, right? And then the directions, it says radius and diameter. So r equals and d equals. Oopsie. Okay, so our radius is 9. 9 what? Cows, chickens, moons? It's going to be feet. So this is going to be 9 feet for our radius. And what did I tell you about the diameter? A radius is from the center out to the edge of a circle. A diameter would be the entire thing. So there's 2 radii and a diameter. So this is going to be 18 feet. What I want you to do is go ahead and try 5 and bring that to class. It's the same thing except they got a decimal in here. And what I want you to use is 3.14 for pi on this one. Try to use 3.14 for pi on this one right here. This is going to be radius, diameter. There we go. Now it's all fixed. So you try 5, bring it to class. Let's see what you get, see if you get the right answer, and we'll talk about that when I see you in there. So let's keep going. Now we talk about area of a circle. Pi r squared. So we take the radius, we square it, and we multiply it by pi. So let's use that formula in number 6. On number 6, it says find the area. This 5 right here, is that a radius or diameter? Well, it's from the center to the edge, so this must be a radius. So if the area is pi r squared, we're going to substitute in our 5 for our r. So the area equals pi times 5 squared. Now, don't do pi times 5 first because you have to take care of your exponent. 5 squared is 25. So we have 25 pi. And that's our area, 25 pi. What are the units here? We're talking about area. And that 5 right here, those 5 inches times 5 inches. And inches times inches, inches squared. So 25 pi inches squared is your exact area. Let's look at 7. 26, is that a radius or diameter? It's for sure diameter. So if we divide it by 2, we'll get our radius. So 26 divided by 2 is 13, and that's our radius. We're going to use the exact same formula. So A equals pi times r squared. We're going to substitute 13 in for the r, so A equals pi times 13 squared. And then we're going to do 13 times 13, or 13 squared on the calculator, and you get 169 pi. So 169 pi is our area, but what are our units? It's area. And you did 13 kilometers times 13 kilometers here, so that's going to be kilometers squared. What I want you to do is bring number 8 with you to class. So finish up number 8, bring it to class. It's very similar to number 6, so hopefully it'll be easy peasy for you. So bring number 8 to class. Ooh, let's look at 9 and 10. So getting a little deeper here. Please find the exact area of the shaded region. So you're going to have to actually pause and think on number 9. What fraction of the circle is shaded? You have to ask yourself that question. So in class, when you're practicing these, I want you to ask yourself that question. What fraction of the circle is shaded? And you know what? I'm going to do number 10. Look at this circle. I'm going to write in red. You don't have to write this down unless you want to. How many pieces of the pie are there? 4. How many pieces are shaded? 3. So in this picture, 3/4 are shaded. So when you find the area of this circle, you only want 3/4 of the area, okay? So 3/4 are shaded. So let's just find our area first. So area is I messed that up. Area is pi r squared. Well, our radius is 8, so we're going to substitute that in for our r. So area equals pi times 8 squared. 8 squared on the calculator is 64. So area equals 64 pi. But we don't want the area of the whole entire circle. We only want the area of 3/4 of it. So you want 3/4 of your area, like that. Now, if you're struggling with 3/4 of 64, you could do it in the calculator. So I'm going to do 3 divided by 4 and multiply it times 64. Notice I use parentheses, and I get 48. So our area is 48 pi, and what are our units? Feet. Are these square or not squared? They're squared because they're area, okay? I want you to try number 9 and bring it to class. So finish up 9, bring it to class. Think about how much of it's shaded. It's 1/4. All right, let's go down here and talk about 11 and 12. So I'm going to talk about 12 actually. That's a little bit tougher. It's very similar. Actually, no, number 11 might actually be tougher for you. Maybe they're both tough. Who knows? I'll do 12 though. So let's look at 12. To me, you have to look at this and you have to think, what is going on? And to me, what looks like it is a rectangle, right? And they punched out a circle. So you're literally going to work it out that way. So first, let's find the area of the rectangle. Base times height. Base times height. So this is going to be 11 times 8 minus the area of the circle. And you're like, Storvik, there is no radius in there. Well, there is. If this is 8 feet, this is 8 feet. You got me on that? So if this whole thing is 8 feet, what's your radius? Your radius is 4 because it's half the diameter. So it's minus pi r squared, but our radius here is 4. So 11 times 8 is 88, and 4 squared is 16. So we have 88 minus 16 pi. Guys, these are not like terms. One has a pi, the other one does not have a pi. Please don't try to put them together because they are not like terms. So your answer is literally 88 minus 16 pi, and it's area, so feet squared. Okay? If you want to, go ahead and try 11. I'll give you a little hint. If this radius is 16, guess what the length of this is? 16. And does this look like a square to you? This radius would be 16, so the length of this side of the square is 16 also. So 16 by 16. Mark it down now on your paper. 16 by 16. That'll give you a big hint. All right, so finish those problems up, bring them to class. Remember, you can rewind, rewatch, you can pause, do whatever you need to do. Learn at your own pace in this video. And I will see you in class. Bye-bye.